Here we have our standard 4x4 square. We can imagine a squaring function inside or reciprocal function, some other function. We can imagine one function or another inside of this, okay, exponential function. But we don't need to specify that right now. What we want to do is just want to take the square and double the distance of every point from the x-axis. Okay. Now I say double distance from the x-axis, we really mean double the distance of each point. And that'll be each point on the square, on the boundary, and inside the square. We want to double each distance of each point from the x-axis, then shift each point 6 units horizontally, and shift each point -3 units vertically. Well, how do we do that? Well, let's double the distance from the x-axis. These points are all on the x-axis, so they're going to stay there. If you double, your distance is 0. If you double 0, you get 0. Okay. Now, this point has to double its distance. That means it's going to go up to here. We could either draw an arrow that shows where this point goes, and an arrow with where this point goes. Okay. So it's really equal heights, I'm going to move that. And then each point here, we've got the relative distance, and they're all going to go up to here. So now we're going to end up with this 8x4 rectangle. Then we're going to shift 6 units in the horizontal direction. Now, where's 6 units? Well, this distance is 4. And this x coordinate would be 2. Here would be -2. Here would be 2. So if I move this far, I have 6. Here would be 4. A little further would be 8. And so if I move this point 6 units in the horizontal direction, it's going to go out to 8 because of course 2 is 8. So let's see, move here. Going to move it here. And every point on this boundary is going to move that far. This point is also going to move that far. So our right boundary is going to be here. The left boundary is going to move 6 units. I don't want to draw arrows on the left boundary because they don't confuse with everything. But we go from -2, we go 2, 4, 6 units. We're going to end up at 4. Like vertical. And let's I should have made this a dotted line. Make it a little bigger. Just be a dotted line here, here's line 6. Anyway, here it is. So here's our original rectangle. I didn't get the shape quite right. There it is. Okay, so we shift 6 units horizontally, and then we shift -3 units vertically. Which means every one of these points will go down 3 units. Now, there's 4. Get some sort of scale here. Base of 3 units, bring it down to about here. So we take this point and move it down 3 units. At this point, move it down 3 units. At this point, move it down 3 units. At this point, move it down 3 units. Not being real consistent about my scale here. we can see now that we've got this rectangle. So if we originally had a parabola here, we can simply draw a parabola inside of this rectangle here. And this parabola have the same shape as this, except it's stretched out by a factor of 2. So it looks longer and skinnier. And then it's shifted over and shifted down. Now, a couple of flaws in what I did here. These arrows are supposed to be 3 units. Yeah, these. Okay, well, I'm thinking I'm kind of okay. Now, what I'm going to tell you is that this is the y equals x squared parabola. This parabola. Now, we've already seen that if you shift 6 in the horizontal direction and -3 in the vertical, you're going to have something like x minus 6 squared minus 3. But we haven't done anything about the fact that we stretched it. Well, that's taken care of by a number out here. So here's our stretch. Our horizontal shift is 6. And our vertical shift is -3. And here we see how to do this. Now, seeing this after you've had function notation. F of x is your x squared function. A equals 2, H equals 6, K equals -3. That's the function notation representation of what we just did here. And it doesn't depend at all, at least this expression works not just for the f of x equals x squared function, it could work for any function. Now, if you haven't seen function notation yet, or you don't remember it, that's coming up very soon. And what we're really getting at is the way we can construct new functions from our toolkit function. And these new functions ultimately have important meanings for the applications that we need to use them for.